All right, it's Mr. Rops here, and today we're going to talk about sample space and bias. And this one's specifically going to be about sample space. And what a definition of a sample space is, it's all the possible outcomes of an experiment or a situation. You can represent the sample space in a variety of ways. We could make a list, we could use a two-dimensional grid, or we can make a tree diagram. So if we consider this situation here, we have a bag of green beads, white beads, and purple beads, and a coin that can land on heads or tails or heads. Okay, and so a bead is chosen at random from the bag. So if you imagine I have myself a bag here, here's my bag, and inside my bag I have a green bead, I have a white bead, oh my goodness, I'll do a white bead, and we'll have a purple bead. Okay, and then I also have a coin that I know my coin could be heads or it could be a tail. So when I consider this scenario, if I'm going to make a list, I have to make try and do it in a systematic way. And so if I first come along and I pick up my green bead, so I could have a green bead, but I could have a head, I could have a green bead and a tail. I could have a white bead and a head and a white bead and a tail. And so making a list is basically systematically going through one by one and considering all the possibilities. I could have a purple and a head and a purple and a tail. And so that is considered every single situation that is possible. And so it is what we call just making a list. It helps to do it in an organized fashion. The 2D grid is similar, except it does it even more organized. So here I have three possible outcomes. So I'm going to have one side be three possible outcomes, so green, white, and purple. And over here I'm going to have my two possible outcomes, heads and tails. And so a grid looks like this kind of a scenario, like a box. And then I look and see the combinations here. So I can have a head and a green, and a head and a white, and a head and a purple, and a tail and a green, and a tail and a white, and a tail and a purple. And so in this case, the order doesn't matter, but this is another systematic way of making a list. And it's just making sure you don't miss any possibilities. And then the final scenario is a tree diagram. A tree diagram is a scenario that when you start off the first scenario, let's say from this problem, I first am going to take a bead. So that means I have three possible outcomes for my bead. So I could have a green, a white, or a purple. So here is the first event. And then from this first event, I can do my second event, which is if I have green, if that happened first, then when I flip the coin, I can have a head or a tail. If I had a white one, well, then my options, if I did white going down this branch, it will be a head or a tail. And if I go down this branch, if I pick the purple bead, then again, when I flip the coin, it could be a head or a tail. And so again, I get GH, GT, WH, WT, PH, and PT. And so you can recognize all the different possibilities that there are. And this idea of sample space is actually quite important, that you recognize all the different outcomes that are available for your situation. When I first started teaching, I didn't think this was an important idea, but I've learned along the way that it's really important that you stop and think about what are all the possible ways or outcomes that are possible in your experiment or your trial of events.